Uh, so as all of you know that week 9 graded assignment is extended, so I think it is still Friday. Okay, so
Yes.
so this is the first session for week 9, and I will keep it as a activity practice session. So what we can do, like I will take your first doubt. So all of you gone through week 9 lecture. So let me present my screen.
Sir, what do you do if you're unable to attend the quiz to exam?
If you are unable to attend, so like
Yes.
it will be like you are able to give the interim, and the there is one process to the grading, which one some grading document were there, right? There is a grading document. If you are not attending quiz 2, then that's fine, but according to your quiz 1 marks, the marks will be evaluated for grading. Okay.
Okay, sir.
Okay, so please raise your hand one by one. First, I will take doubt. Okay, so that who is here for just for doubt, I will clear those doubts, whatever you have, and then I will do a summary thing. So in week 9, we have maxima, minima, the critical points we will see, and then Riemann sum. Riemann sum is nothing but a kind of integral. Taking the integration, some different concept is there for the Riemann. And then yeah, that's all for week 9 we have. So please raise your hand one by one. Let me see, anyone have doubt? Okay, yeah, Raja.
Yes, sir. In the activity first activity, there is one question related to trigonometric function. So that one, if you can explain it, how to approach it.
Okay, so which question number? This one.
Yes, sir. This one, 7th one. Yes.
Yeah, that's why the hint. If you'll see that, see here, the hint is given. So here is assume fx doesn't have a saddle point. Which of the following may represent the graph of a function? So what is in this problem? You just need to find the number of critical points, and this function fx does not have any saddle point. So that means, at least in this interval, whatever the interval is given, so at least in that interval, whatever you have the critical point, no, that will be a maxima or minima.
Okay.
So that means it will be either, means in another word, you can say that maxima, minima, or turning point. It doesn't have it does not contain any saddle point. Saddle points means what? Do you familiar with when the graph will contain, or when we will say while looking the geometric thing, can we say which point is going to be saddle point? Are you aware of that?
Sir, in the lecture it was told something like f double dash of 0 is f double dash of that value will be 0, right, sir?
Yes. And also like that where the graph, the x cube thing, the function fx is equal to x cube. If you see here, for x cube, it will be there will be S shape kind of thing. So it will be like this. It will be look like this on origin here at 0. It's look like a critical. Sorry, it's look like a critical point means, or it's look like a maxima or minima point, but it is not. The reason is, if you see it, this function, it is continuously like increasing. The saddle point means what? Saddle point means there you will find the slope is 0. but still the function is continuously, it will be either increasing or decreasing. Either it would be increasing or it could be decreasing, but it will be not the form of like it is increasing and then started decreasing. So here is the maximum, local maximum is this. This is a turning point or critical point. So this is also a critical point, but the reason is here is not, this point is not becoming a turning point. Like it is continuously increasing and increasing. This is the mean of saddle point in geometry. Okay.
Okay, sir. Got it, sir.
Yeah. So now if you check there, just need to find, you have to find the critical point. Here is the formula is given when you will see, if this one as a hint, if you see here, the cos x plus sin y, cos x plus cos y is equal to 2 into cos x by, this is the formula I have written. Based on that, on cos x and cos 3x, here is written that differentiate the function fx and then use the formula this one on cos x and cos 3x. If you differentiate this function, okay, and then use this, it will become cos and this will become cos 3x. Apply this formula on this one, this once you will differentiate. Okay, this is the mean it is saying. And then solve the equation f prime x is equal to 0, means you need to find the critical point. And once you find the critical point, if cos x is equal to 0, then that means x is equal to pi by 2. Almost solution is given here, pi by 2 and 3 pi by 2. That means in this interval, only 2 points which have cos x is 0. So which figure contains 2 critical points? Can you tell me?
Third option.
The third option, it contains 3 critical points, right?
Oh, okay. Sorry.
This one is means this one is local maxima, this one and this one. There are 3 local maxima or minimum.
Fourth option.
The fourth option, it contains only 2 critical points. One
Yes,
is local maxima, local minimum. So while looking itself in here, you can tell something. Okay. So Devanshu have some doubt. Yes, Devanshu.
Yes, sir. Sir, I have doubt in activity 9.1 question 10.
Then 10. Oh, and this is 9. Suppose
Yes.
function you have given sin x. Suppose there are k critical points and n zeros of fx in the interval minus 10 to 10. Then find the value of n minus k. So minus 10 to 10.
What is the difference between critical point and zeros?
So zeros and so that's why I meant to say that, you know, all of you gone through the polynomial, no? So there, what do you mean by the zeros of a polynomial?
Values where the
When the
polynomial
graph
takes
cuts,
an
etc.
intercept.
The roots, whatever the zeros are actually the roots. And what are the critical point? Critical point is zeros of the derivative of. Critical points are zeros of the derivatives, right? And here zeros of fx is one thing, and critical points is what? Where the derivative is 0. That means you, in different word, you can say the critical points are zeros of the derivative of the function, right?
Yes, sir.
So you have n zeros for function fx, and there are k critical point. So how many this? So just use for like for the time being here, you need to use, you can use here the Desmos, or this interval is given minus 10 to 10. You can
3 by 2 minus 3 pi, sir.
So how many zeros will sin x contain?
7.
7 zeros. Like if you see here, sine graph is like the interval is given minus 10 to 10. Minus 10 to 10. So that this means what will be the in the radian form if you see it here? How it will be? Pi value is what? 3 point something, right?
3.1. Yes, sir.
Then if you multiply 3 pi something, then it will be approx 10. It will reaches to 10 something. It will not
Yes, sir.
exactly. That means from this, suppose this is pi, then this is 2 pi, and this is 3 pi. Similarly for this side, minus pi, minus 2 pi, and this is minus 3 pi. So at least in this range, you need to draw the graph of sin x. So it will be like this. At pi, it will be 0, means at 2 pi, 3 pi, and at minus pi also, or minus 2 pi, and like this.
Sir, that minus 10 and 10 are in degrees.
No, minus 10 and 10 not in degrees. It is in real. It is a numeric thing. It is not in
Okay,
degree.
sir.
That's why I changed it here. No, I just approximated the value
Yes,
in
sir.
at least
Yes.
to know that how like in 3 pi how it will be look like. It is approx 3 pi.
Yes, sir.
So that I able to draw the graph roughly. Now you can count here how many zeros for sin x have. And now if once you derivate that function fx, which is cos x, and again cos x will be what when it will be 0? At
Pi by 2.
pi by 2
3
minus
pi
pi
by
by 2, 3 pi by 2 minus 3 pi by
Yes, sir.
2, like this. And then you count. So either you can use decimas also. That this question is not. This is just for practice. It will not like
Okay,
to be
sir.
asked. Okay.
Excuse me, sir.
Yes.
Sir, you have just now you said that critical points are zeros of derivatives, sir. Sir, I could not understand, sir. What is derivative, sir?
Derivative means derivative means you need to find the, like you have a function sin x, right? So differentiate, just differentiate it. That is the derivative of this function. No, derivative means what is the once you differentiate this function, what it would be? Derivative of sin x. So means
Cos
the
x.
difference. If you see the video lecture of week 8, the derivative means once you differentiate this function, it will be cos x. So this is
Okay.
called derivative of the function.
Thank you, sir.
Okay. Devanshu is, yeah.
Yes, sir.
Devanshu,
Done.
it is done. Yes.
Yes, sir. I have some more doubts in activity question week. I mean 9.2.
9.2. Sorry, your wife
Number
taking
6 and 7.
6 and 7.
Yes, sir.
So in this problem, consider the function. One is a local maxima, and so what?
Sir, how here one is a local maxima? I didn't got that. I solved for
Sir?
that and I only got minus 50 as the global minimum.
Okay. Sorry, somebody is saying something. Yes.
For question 9.1, question 10, what is the answer?
Okay, it will be, I think, how many zeros were there and critical points? So like 7 were, right? This one is okay. Let's check it here. So this is 1, 2, 3, 4, 5, 6. So 6 zeros for sin x, and the critical point is cos x. Now, so it will be go like this. So suppose this is pi by 2, and this is
Sir,
3 pi
7
by
0, sir.
7, no, sir. Origin also.
1
no?
0, sir.
3,
0 is
4,
also there.
5, 6. Oh, here is
7
one,
zeros.
6, 7 zeros. 7 0 it have, and now cos x, once you derivate, which is we got this
Sir,
one.
but
And,
so how 7 zeros 0.3 pi and minus 3 pi are not included, isn't it?
yeah, that's why see 3 pi is 3 into 3.14 something we will do. It will be.
Oh, yeah.
It will not exactly. It will be. It may greater than 10, right?
Yes,
I
sir.
don't know.
Yes.
It will be greater than 10, no?
Yes,
So
sir.
calculator you have to use. Once you will use, then you will get that, and then you will see that at 3 pi. That's why you will not include the 3 pi and minus 3 pi. Now, if you see the graph of cos is, it will be, if it is here pi by 2, 2 pi, which is here is 3 pi by 2, and this one is what? Again, this is 5 pi by 2. Again, similarly here, here, and here. So here it will be like 3 pi by 2 and minus 5 pi by 2 at these points. So like at 0, the value is 1. And at minus pi by 2 or pi by 2, it will be cos like this will go. And similarly, this one.
Sir, if we solve it by weak 4 concept.
Now you can count for zeros for causes. This one, oh, sorry, this is one. So how many zeros here is happening? This one, 1, 2, 1, 2, 3, 4, 5, 6. So one is, I think, answer will come.
Yes, sir. 1.
Yes, sir. Answer is 1.
And the cos for sine I counted 0 is here. Not this is not zeros. These are the zeros. These are the zeros here. I forgot. I just calculating for the
Sir,
max local number.
Sir, I have a small doubt on
Okay,
this question. If we apply weak 4 concept, where
Which function?
from the weak 4 polynomials, turning points and roots. So roots are always equal to the degree of the function, and turning points are always 1 less. If by that we go to, in that case, it will be always 1.
No. So that is applied for only polynomial, no?
Yeah.
So here is also you are applying.
Yeah, I'm also trying to apply the same concept over here. Also.
No. So here for this one it will not work, no? Because
in this case it worked, but in other cases may not work. That's I want to clarify. If you see here, the number of roots and number of turning points, there is a difference of only 1.
For trigonometric function, that would not work.
In this case, because it is a sine wave, it is always having a turning point at some interval, and also meeting at x some point, x axis at some point.
So okay, so let's discuss the ahead question, which is this one. So in this problem, we need to find the local maxima and local minima, or global maxima and global minima. Okay, so in this problem, how we will do? We have to find the first critical point separately. Separately means here at least for this function and this function, and also we have to check that is this at 50. 0 2, yeah. So it is written in the. So at 0, so it will be like this. It will be, this line will be go up to this one. So the function will be looking like this. So here is not wrongly written. It is not written in order, proper order, which is fx is equal to. This function is x cube plus 3, which is minus 52 x2 less than 0, and the next one is minus x square plus 2x plus 3, minus x square plus 2x plus 3, which is here, okay, 0 x and greater.
So your voice is cracking.
So at 0, we
Your
have
voice
to
is
check
breaking, sir.
the difference will
Your
be.
voice is not
If it
clear.
is, then it will not be a critical point. And okay, let me check. Okay, so now is it clear?
Yes, sir. Right
Yes,
now
sir.
it's smooth.
Yes, sir. Clear.
Okay. So here we have to. So here we have to check the, yes. Sorry, my voice is clear, right? And not breaking anything is there.
Yes, clear.
Yes, sir. It's all right.
So
Yes, sir.
like at here is first we have to, let's check for this interval. You have to check at least for this interval. Okay, somebody is saying okay for okay. Okay. Okay, so like at least in this interval we have to check the critical point. So for interval
Can you also explain what is local and global maximum minimum?
so what is that in this problem? We have to find the global maxima or minima and also local maxima and minima. So we have to one is a local maxima.
So what is
So
the
one
difference
will-
between the two?
Sorry.
Sir, what is the difference between local and global?
Local and global maximum.
Okay, so local and global means, let's see here this in geometric format, then it will be good. So geometrically we can see it here. Suppose we have a function, okay, like this, and at least in this interval I am just worrying about this function, okay. At least in this interval I am worrying about, and also okay, just not this one, at least till here. At least in this interval, let's say this is A and B. So these points are local. This is local maxima, this is local minima, local maxima, local minima. But suppose here is, I mean to say here is a bullet point. That means here the function is attending this value. Okay. So this point is going to be the local not global maxima. Global maxima means at least in this
So which
interval
point are you
A to
talking
B.
about?
At which point? Sorry.
So which point is the global maxima or minima?
So these points are local maxima or minima. So this is the local maxima. These are the local maxima. This is the local minima. This one, and here is the local maxima. This is local. Sorry, this is local minima. This is local maxima. Here, this point is going to be global minima. Global minima. The definition of, you see, the global minima is means what? Global minima means here at this point the function attain the minimum value at least in this interval. In this whole interval, this closed interval A to B, this point, let's say this is the function value is, suppose this is alpha and this function value is f alpha. So f alpha is less than for all value, less than for all value of fx. Okay, x belongs to A to B. Is this whatever I have just written in this mathematical format? Is this clear?
Yes, sir.
Yes, sir.
Yes, sir.
F alpha value is less than or equal to function value for all, at least in this interval, for all value. So if you compare this value,
Sir, your voice is breaking.
minimum value in this interval for this function, and at least suppose here is the function value is attending. So definition. So this is for okay. I hope it is better now. Is it?
Yes, sir.
Yes.
Okay, now I think it will not break. Okay, so here is, this one is global minima. Okay, and so global minima is at x is equal to alpha, and minimum value, that global minimum value is this one. And similarly, the global maxima is going to be the value, that value, let's say this is, or I just wrote here, no? So let me erase
So what is
and
the difference between global maximum and local maximum?
sorry.
Difference between global maxima and local maxima.
So that's why I'm saying, no, this value, see, is this not clear? This is the mean of global minima or global maxima. So this is the meaning of global minima. So global minima is, if you compare this value, so there are some values like this is the local minima. The reason is there, or this one is local minima as this value is less than this one at least, but still you will say this is the local minima. But this value here, this f alpha value is less than for all value if you compare the function, whatever the, if you compare the whatever the value you will get for at least this interval a to b, it, at least in this interval the function have at here the minimum value in compare of the whole values of whatever you in this graph it's representing. Okay, this is the global minima. Now similarly global maxima is, suppose this is beta here. Okay, this is beta here. So fx or f beta is greater or equal to fx for all value of in this interval. This f beta value is greater than for all value of fx in this interval. If you compare this value, so this one is, see that this is local maxima, maxima. But if you compare this value with this value, this is the greatest one, and this is the lowest one. So this value is greatest one in compare of whatever the value you have in this interval. So that's why this point where it attains, this is a global maximum.
So it means that the highest, the maximum value.
Yes, maximum value in that interval.
Global maxima is the maximum value and global minima is the least value of all the values in that interval.
Yes.
And global maxima is also called local maxima, right?
Yeah, you can call this is also a local maxima, but it is also a global maxima. Okay, you can call it this is a local maxima. There is no issue because this is also a value.
So what if in that case, if there are two local minimas which are of equal and they are the maximum value at maximum fx, then which one will be global?
Which one is not global? You have to compare which value is greater than for all value of fx, not in compare like this one is. If you compare, this is some higher. This value is greater than this one.
So
But you cannot compare. You have to compare with the all value of fx, not only this.
Yes, sir. I got this concept. For example, the global maxima point that you have mentioned, and there is another local maxima which of equal. It is equal, which has same equal value. Then which one will be considered global one?
Anyone. So you can say that point contain two global maxima. If it two values are equal, okay. Suppose here is also function value where this one is the same value here, whatever here is, or you can say this point is also same value it attains. So it have two global maxima. Means at 2 points it attains the maximum value.
It means a function
But
can.
the function value is, if you see that whatever the function value is here, no, it will be always. See, this value is same, right? This value is same, but at this point, at two different points, it attains the same. It attains the same value. That's the difference.
So it means a function can contain multiple local maxima and multiple local maxima.
Yeah, it may contain. Yes, it may contain.
Yeah.
Okay. So, okay. So for this problem, so what we can like for this problem, we have to go with the local maxima. So it says one is a local maxima. So find where one will be. It will be here. So just derivate this function first. You have to check that is this a critical point or not. Okay. If it is a critical point and it attains the f prime, you know, it means you have a function in this interval. This is minus x square. This one you have. So you have to derivate that function at least in this interval. Okay, just derivate that, it will be minus 2x plus 2. Okay, so at 1 it is becoming a 0, minus 2 plus 2, right? So this is 0 at 1. F prime is 0. That means 1 is the critical point. But still you have to check, is this, the option says, right, the local maxima or local minima, but you have to check that F prime 1 should be less than 0. Then you will say that it is a local maxima. So just derivate that F prime, just find that F prime. So it will be what? -2, which is less than 0. That means 1. Yes, 1 is a local maxima. That option is going to be correct. Now, and another, now next you have to find the, so -50, this option is says -50 is a global minima. So what it means that -50. So the function first attain the global, -50 is global minima. Is this in this problem? So you have to check that at what is the value at 50 here?
Minus 1,24,997, sir. Minus 124,997.
Okay, so at minus
Excuse me, sir.
50, yes.
Sir, may I ask you, sir, if in a place of 1 we have a 2, so then it is also a local maxima.
Sorry, could you repeat, please?
If in place of 1, if we have a 2, then it's also a local maximum.
Yes.
In that case.
Yes.
And also for others number 3, 4, 5.
Yeah, it could. Yeah, there is a possibility. So what is the process to find the critical points? You have to derivate the function and equate to 0. So as here, if you equate to 0, here is, you will get x is equal to what? 1.
1.
So only one critical point at least in this interval.
Okay, sir.
Okay, where
Yes, sir.
which is 1 and which 1 is a local maxima. So now we need to find the, now we have to check that 50 is also. So what is the value of 50 is here? F50 is going to be what? Here is, this is -50, so this is 50. So this is -50 square plus 50 into 2 plus 3. So here is this one, no? Plus it is 100 and this is 3.
No,
This is going to be minus kind of thing. Minus value will get. So how it could be the global maximum? So it is says maxima or minima? Oh, global
Maxima,
minima.
sir, the limit, sir, the limit I
Maximum.
think that wrong, sir.
Sorry.
The limit you took is not the correct one. Minus 50 cube, no, sir.
Oh, -50 cube. No, here is 50 is asking for, oh, -50. I check for this one. So okay, -50 I have to check. So for 50, let's check in, like I am checking for 50. So 50 is this one. The 50 we got value this one, whatever the value is coming here. And at -50, and what is the -50? -50 is going to be, this function will work. So -50 cube plus 3. So whatever the value will get, we don't, so just need to calculate it here. But still we have to sure that is there any other function which is, sorry, is there any other point which give the lesser than value, which is 50 or -50. We have to check that. Means, is there any other point? Okay, is there any other point in this interval where the function, the whatever you got 50, -50 or 50, is there any other point, let's say alpha, okay, that these values are lesser than that, or no, sorry, this value f alpha is going to be lesser than the both? We have to check. If it is not, then we will say this is going to be any one of them. So we have to check this -50 we got 2, 4 something, and this, sorry, at 50 we got this one, and -50 we got this one. So we know here is what we are getting, this -50 is lesser than 50, right?
Yeah. Yes, sir.
-50 is going to be, at least we know that we compared and we got that -50 is lesser than at 50. Okay, function value is going to be that. So, but still we have to find, we have to check that where it is going to be, like it is going to be minimum value of the function in the interval. The whole interval is asking, yeah, in the whole interval it is asking. Oh, sorry, -50 to 50. Here is the function is given to -50 to 50. At least we have to check this function -50 to 50. So generally, what is the rule? There is one rule is that at the ending point, it generally is there is a possibility that at the ending point, means here, the function contain the global maxima and minima, but may not sure. But generally, this is a, you can say there is a general trend. You can say many times it's have seen that at the ending point the global minima or maxima happen. But no issue. But still we have to check with the mathematically that we are fine with it or not. Is that going to be global minima or not? So how we will check? How we will check? Anyone can tell how we are sure that minus 50 is going to be global minima? So here the pictures come for increasing and decreasing function. You have to at least see here, right? You have to be sure with the increasing and decreasing function. Then it will be you will be sure, right? So here is in this range here. The function we have x cube minus 3. So this function is what? It is a increasing function, right?
Yes, sir.
It is a increasing function. So for minus 50, at minus 50, it will be the minimum value, at least for this one. We have to check for this one also. So at this range, what about this function? Is this increasing or decreasing?
Second one is decreasing, sir.
It is also a decreasing. It is also a decreasing. Sorry, it is increasing, but it is it is decreasing. Yeah, this is increasing, but this one is decreasing, right? This is a parabola. All of you gone through with the parabola, no? All of you are able to draw this graph also.
Yes, sir.
X square plus this is minus here, so it will be downward. It will be open downward. So it is a decreasing. So at least if you check here the symmetricity, where it will is symmetry, it will be minus b by 2a. So this is minus
1.
b is 2 and 2 by minus 1, which is 1. At 1 it is a symmetry.
Sir,
At
1,
1,
not minus 1.
yeah, it will be at 1, it will be symmetricity. So that means what? And this is the function we have, and vertex we don't know what at 1 what is going to be the value. At 1, this is minus 1 plus 2 plus 3, this is 5, and this is 4 you will get. So suppose 4 is here. So this side is like this, because at 0 the function is defined like this, and this side is continuously decreasing till 50. Roughly you have to, okay, this is a steep, it will be very fast. Suppose here is 50. So it is continuously decreasing as here. So at minus 0 to 50, it is sometime increasing, but after 1 it is started decreasing. So till 50. So that means at least in this range, at 50 it will be the lowest value. Okay, at 50 the function contain lowest value in this range. Now can we conclude something now? And also we have concluded this one, no? This one. This one. We have concluded this one, and we have also concluded this one. Now can we say now we are very much sure that we are reaches to a surety. What is the sure thing is we are getting? What is the sure thing?
So
1
50
is
is
local maxima and 50 is minima, local minima.
No, minus, no. Assure thing is about the global, we are assuring with the global minima. So we have actually reaches to minus 50 is lesser than 50, right? This is also continuously decreasing.
Sir, your voice is breaking.
Here, but we got that minus 50 is lesser than 50 function value at there. Okay, clear. And in this range, the function we have like this. If you see that here, this one. So at minus 50, it will be like here. If you roughly see the graph. Also, so if you compare this here with this one, so minus 50 is going to be lesser one, at least in this one, in this interval. So that's why at f minus 50 is going to be global minimum. Okay. Is it clear now? I think, am I audible?
Yes, sir, it is clear.
Yes, sir.
Yes.
So see, so I roughly draw here the function graph, but still you have to be with the increasing and decreasing function. That's why using that you have to conclude. So see, that's why the function is given, like you are able to conclude also. If it is given in the polynomial, still you have that's why all of you gone through with the polynomial thing. You are able to something draw the polynomial, in which interval, how the polynomial will behave. So as here, we know that at least in this interval 0 to 50 function, we have it like a quadratic. So at 1 it is a quadratic, at 1 it is a vertex here, and in this interval it is going to be a quadratic. So here after onward, here it is started decreasing, as you can see right here is the -1 is minus. So if it is minus here, then it is what? It is open upward or downward? It will be open downward. So like this, the graph will be, this is correct one. So till 50 reaches that, okay, in this interval, this is going to be, for at least in this interval, this is going to be, my F50 is going to be lesser one. Now we have to check with -50 in this interval. So in this interval, at this point is going to be the minimum. Now we have to compare this one and this one. So in starting, just now we have compared that F50, this F minus 50 is lesser than F50. So finally we can conclude that F minus 50 is going to be global minimum. Okay. Now is it clear?
Yes, sir, it is clear.
Anyone have still doubt? Please let me know, because we almost discussed about the global here. And also once I will start revising the thing, this is the best example to saying that what is the global minimum, global maximum.
Got it, sir. That's why how the formula comes minus b by 2a from the derivative.
Sir, if you can please once explain question number 7 too.
So you are not audible.
I think sir is not there.
Oh, I also feel like that.
Yeah, connection lost, right?
Yeah, I just muted. Okay, so yeah, is it? It is not clear. Whatever we discussed, it is.
Yes,
Am
sir,
I
it is
audible right
clear,
now?
absolutely.
Am I audible?
Yes, sir.
Yes, you are audible.
Sir, you are audible.
Okay, so let's move ahead, and I think no one have doubt. Okay, so let's discuss the theory part. So
Sir, actually I have a doubt in question number 7 and 8 also. In activity number 1.
okay, so is that okay if we want to do the summary? Then I will
It
take.
is too short, sir. You can just take 5 or
Okay.
6.
Okay,
This
so
is
which
over.
question number?
So 7, 8.
Sir,
The same activity.
hello, sir.
Yes.
Sir, it will be, I think, local
Yes.
maxima, global maxima will be very much clear if you give
Sir.
an example. I mean,
Sir, move forward, sir. 8th one. And the eighth, ninth, you just give solutions.
Yeah, yeah, okay.
How to
So
solve, then I can solve.
let's back. We will discuss again. Okay, we'll discuss again there. So this in this problem.
Yes, sir.
Okay. So what's your doubt? Which of the following is maximum value of the function interval 0 to pi? So here you have a trigonometric function is given. So you have to again use that. You know, we have discussed something or.
Yes, sir. Yes, sir. I got it. That's one third one.
You have seen
Your voice is not clear.
which question number now? Then
So now you can
the
move
same
to 9-1,
which-
9-1, 9-1.
Okay.
How to find that one, increasing in which interval? So we can't take it directly, direct put it and get answer.
In this problem, this ninth one. In this problem,
Yes,
ninth
sir.
one is the. So again, in this problem, the function is increasing interval and decreasing. So you know you have a.
What's up?
So, yeah.
Actually, your voice is not clear,
Discuss
sir. It's
using
lagging.
this one. There is one concept we will again discuss. This is an important concept. Okay, just wait. Is it better now?
So now it is better.
Yes, sir.
Okay. So there is one concept behind it. So in a brief, we can discuss that concept also. So if you have a function fx, okay, if you have a function fx, so if you derivate this function, okay, and suppose the derivative is less than, okay, suppose your or either way, suppose you have this function and it is defined like this, some interval a to b, okay, c to d, and d to e, some interval is here, okay. In this interval, the function is defined like this, okay. Suppose this is whatever the thing is there, we'll discuss that. So this function is defined like this, or any function. This is I just chooses for to more convince, like you will get more. It is easy to understand that. So suppose f prime x is less than 0 in this interval, okay, in this interval, or at least like this, or close and open interval. So this says your function is decreasing in this interval.
But it's opposite way, that
F
one.
prime x is, sorry, and if
Sir,
f
no,
prime x
nothing.
is,
You can move forward.
sorry,
Continue,
I just
sir.
started.
Continue.
Okay, so if f prime x is greater than 0 in interval, let's say f in this interval, then the function is increasing in this interval. For example, let me take an example. Suppose your function is defined fx is equal to, or let's take a simple example. Okay, the function is defined like x, or the same quadratic, x square plus 2x plus 3. Okay, I'm taking the same quadratic function. Okay, and let's derivate this function f prime. So this is going to be minus 2x plus 2, right? So
Sir, prime means derivative.
so prime means here that I'm just differentiating. Yeah, so derivative means this is the mean of d of f. Okay, means prime means I'm derivating this function with respect to x. I'm getting this. So this is the derivative. Okay, so here is in this interval. So here we got the derivative of the function. So if please stop me if I am using different word also, if you are not getting that word derivative or differentiability. So there is
Sir, you can.
if there is a difference between derivative and differentiability. That differentiability says the function is differentiable at that point or not, and derivative of the function means you have derivated this function with respect to x and obtained function after derivating, like after doing the like sin x you have. So if you differentiate this function, it will become cos x. So similarly, if you derivate this function, it will become, you obtain this function using which formula? X to the power n. And if you differentiate this function, the derivative will be n times this one. Okay, this is the formula. So using this one, you can find easily. This is going to be the derivative of the function. Now find the critical point. It is easier to decide in which interval the function is going to be increasing or decreasing. So here, where the function, this derivative is going to be 0 at, means here is, you can make it equal to 0 or find the critical points here. So at x is equal to 1, so you got that x is equal to 1, where this f prime x is going to be 0. Now it means that, now what is the process? Suppose your function value is lesser than 1. What is going to be the value f prime in this case? If x value is lesser than 1, what is going to be in this? What is going to be the f prime x, the derivative of the function?
Be less than 0.
Minimum.
It will be lesser than 0. That means, I don't know how the graph, but suppose 1 is here, so lesser than 1 value, the function is going to be
Decreasing.
less than, right? The function value is going to be, the function
Below
is
the
going to
axis.
be okay, so I think then I made a mistake in this graph.
Yes, so actually, when we put the 0 on x, value is 3.
Sorry.
Value of y is 3 when we put the x is equal to 0.
If you substitute
That
here,
means y intersection.
okay.
Y intersection.
So yeah, that's, I think, okay. So yeah, at 3 is going to be 0, and at 0 it is going to be so at 0 it is going to be 3 here. So I just strongly draw this graph for the convenience. Okay, so it will be different graph because same function I am taking. So at, okay, for example, so here is the function is, when the function is lesser than 1, the function is decreasing. So it will be
sir,
like this.
if x is less than 1, how can f dash of x be less than 0? For example, if x is equal to -2, if I substitute that in f dash of x, then it will be 4 plus 2, which is 6.
Oh, so it is going to be 0. Yes, so somebody says I didn't check, it is going to be greater than 0. So that's why I also a bit confused with the graph here. I thought, okay. So here is, if it is less than 1, then how it will be? F prime is going to be greater than 0, right? Or somebody says less than, and I started from there. Okay, sorry for that. So in this, if x is less than 1, it is going to be greater than 0. You can easily check here, because it is going to be 1/2 or some value. It is, this value is less than at least this value, and that's why f prime is going to be greater than 0. That means here, so that's why here I bit confused. Here is 1, so at least here at 0 the graph will be like this. So in this interval, at least lesser than value, the function is increasing like this here. And if x is greater than 1, what is going to be in that case? F prime x is going to be lesser than that. So that means your function, that the function is increasing. So by this way you can confirm also by finding the critical point. Okay. After finding the critical points, you can confirm that where the function is going to be increasing and decreasing. So this is the one important thing I want to discuss that. So also the critical point, critical point is a turning point in different way, you can say. So see, that's why here is at 1, the function is start from before 1, it is increasing and increasing. At 1, it is 0, and after onward, it is decreasing. So that's why it is going to be a turning point at 1, or this is a local maxima, and 1 is going to be a critical point. At there, the function attains local maxima. It is going to be the global maxima also if you draw the graph like this. Yes.
When will it
Sir, how
attain
to mathematically find global maxima? Sir, how to mathematically find global maxima?
So that's why I made here, right? I just draw this graph, but I concluded this one with the increasing and decreasing one, no? with the increasing and decreasing. I draw this graph. It is the latter part, but without that, still you can confirm using this one, no? Because f prime give the increasing and decreasing. So using critical point, you can conclude that where the function is going to be increasing and decreasing onward.
Sir, your voice is again cracking.
I roughly draw this graph, but I didn't use this one. I just used this one to explain. But I told you that the function is increasing and the function is decreasing. How it is happening? Using that only I said. Okay, okay. It will be stable, I think.
Sir,
Okay.
please do something
So
with your internet.
this is one part, and this is one. Okay, if you have a function fx in this interval, okay. If you have function in this interval, okay. Still, it is breaking. Am I audible right now?
Yes, sir.
Yes, sir.
Okay. Okay. And my voice is clear right now, I think.
Yes,
Not.
sir.
Yes, sir.
Okay. If you have function this one, if in this interval, if you derivate this function, the derivative is this one. If it is lesser than 0 in this interval, then function is decreasing. Okay. If it is greater than 0, then it is going to be increasing. Okay. This is the mean of increasing and decreasing. Okay. So in this problem, again, I will suggest you just derivate this function, and in the interval wise, you have to check in which interval fx is going to be in greater than 0 or less than 0. Okay. Is that clear now? Somebody who have asked this one. I'm saying this one. Okay. So let's do now for the summary thing. So in the first lecture, it is talking, or the first lecture is on the critical points. So let me tell you in a brief what are the critical points. So by critical point is, am I audible?
Yes, sir.
Yes, sir.
Am I audible?
Yes, sir.
Yes, sir.
Anyone, please let me know.
Sometimes your
Okay.
voice is breaking.
And please let me know if my voice is again, it will break. Okay. So here is critical points is, let's see the geometrically first. So critical point means where the okay. Okay. Okay, let's try it first. Okay. So critical point means there are, first see the definition in this at least in this algebraic form, that if you have a function fx, okay, if you have a function fx, let's say in this interval, if you have a function fx in the interval a to b, then a point, let's say alpha is there, alpha belongs to interval a to b, okay, and alpha is the point. So alpha is, we will say alpha is a critical point if f prime alpha means derivate function, and at there the function value is going to be 0, then alpha is well point. Okay. Alpha function is not differentiable, no? If the function is not differentiable, then alpha is also in that case alpha is going to be also a critical point. Okay. If not differentiable, in that case also the alpha is going to be the critical point. So now let me make a figure here. Okay. Okay. Still let me. So here this means that here, if f prime Am I audible right now?
Yes, sir.
Yes, sir.
Yes, sir.
Okay.
So if fx is
Whatever
not
I discussed, this one, is it clear or still it is breaked? Okay, let me repeat
Clear,
it
sir.
again.
so if
Suppose
fx
you
is
have a function fx and alpha is a point in that interval. So at if f prime is means derivative, or once you differentiate that function at alpha, at that point the derivative value is going to be 0, then alpha is going to be a critical point. And suppose at alpha the function is not differentiable, in that case also alpha is going to be a critical point.
so,
Am I audible?
yeah.
Okay.
So what that point will be called?
Critical point, in that case also alpha is going to be critical point if it is not differentiable, the function is not differentiable at that point.
It is not differentiable when it is parallel to y-axis.
Sorry,
It is parallel to y-axis. In that case, it is not differentiable.
there is more possibility that function is not going to be differentiable at that point. We'll see it geometrically also. Okay, so first let me tell you what it means that f prime 0 means what. So if all of you are there when I was in discussing that, if you have a function fx, then if you take the derivative of alpha, means the derivative of the function at alpha, at that point what it gives, what it means in geometrically,
Slope of tangent, sir.
slope of the tangent. Yes, that's the meaning here. This gives, suppose you have a function fx, and suppose here is alpha, and this is going to be f of alpha. Okay, if you differentiate and you got that f prime alpha is going to be 0 there, it means that, and so if you differentiate that f prime alpha is give the slope of the tangent. So when the slope is going to be 0 for any straight line, it is going to be parallel to x-axis, right? It is going to be parallel to x-axis. So here, if we check that here, at here alpha, at this is the maximum, and also you can say this is a local maxima. It is kind of as it is look like it is a maximum value it is happening at here. And if you draw that slope, or sorry, if you draw the tangent at that point, the slope you see, or if you draw, that is going to be parallel to the x-axis. If you draw the tangent here, it is going to be parallel to the x-axis. That means that's why it is going to be, the slope is also going to be 0 there. So in the other way, in geometrically, you can say that if alpha is going to be a critical point, no, not in this case. For in this case, if alpha is going to be critical point, then surely at that point the function attained, or you can say slope, is going to be 0. Here is as here is happening, or you can different way say, you can say that it is at that point it is going to be attain the maximum, local maximum or minimum also, or either this good possibility, right? At the minimum case here, just draw the tangent here, this is going to be also parallel to the x-axis. Is it clear now? What is the geometric meaning of the critical point? Am I audible clearly?
Yes, sir.
Okay.
Yes,
Now
sir, it is clear, but hello, sir.
Yes, yes.
So it is clear, but if you, I mean, if you follow an example, then it will be very much clear.
Yes, yes, yes. Yeah. Okay. And also, yeah, if the function is not differentiable, in that case, you can say that it is going to be a critical point also. Okay, that's one part. You can remember that this one. Or for that, for example, you know the mod function. Mod function is not differentiable at 0. We know that this mod function is not differentiable at origin, at here. We can check. We have many example in service also did, so you can check. So the reason also, one way you can say, there is in another way, or if you gone through with the tangent, tangent of line, tangent of a graph. There is one lecture in we get. So tangent. So here is, at this point there is no unique tangent. Suppose you are riding a bike on this path, okay, at here. So tangent is actually what is happening.
Can you please tell what question you're explaining, or what are you explaining, sir? Because I had lost my connection. What are you explaining now, sir? Can you please explain that?
No, I didn't get. Could you repeat?
So which topic or which question are you explaining?
I'm just explaining about the critical point.
Okay, sir.
Geometric meaning of the critical point.
Yes.
And also in that topic where the function is not differentiable, that is also going to be a critical point. For example, mod x. If you see that mod x, if you have function, this function is not differentiable at origin. So the reason is also, if you not differentiable means there is no tangent also. So
you mean, sir, there are very much, I mean, infinite number of tangents there.
Yeah, there is going to be infinitely many tangent. Reason is, you can see this one is also kind of, or this one is also, this one is also. So there is no unique tangent. It is not happening a unique tangent or a unique line which touches at that point. There are infinitely many lines which touches at that point. So that's why the function in different way also, you can say the function is not differentiable at origin, at here 0, 0, at 0. So this for this function, 0 is a critical point there. Okay, 0 is a critical point there. Or there is a possibility that, suppose there is a break point. Okay? Suppose there is a break point. So in that case here, the function even not continuous there. Sorry.
It need not be differentiable. Am I right, sir?
Yeah, the critical point is critical means either if it is differentiable, then derivative at that point is going to be 0, or if it is not differentiable, then that point is also going to be a critical point. Like here, this one at origin, 0 is going to be a critical point. And also suppose your function is like this. Okay, there is a break there. So as you know, all of you know, with this is a discontinuous function. So if it is a discontinuous, then how it could be differentiable there? That means this is also a kind of, this is also going to be here. This one is going to be a critical point. This alpha or a is there. So alpha is in that case also going to be a critical point. Now let me know, I'm making a function. Okay, I'm making a graph here. Okay, I'm making a graph here. So this is not smooth, this is corner. Okay, the function is going to be having like this, and this is solid. Here is circle, and this is a smooth one. Okay. So in this interval, can you tell me how many critical points are there? Except this end point, remove this end point. So we are not going to include the end point in that case. How many critical points are going to be there? Am I audible?
4.
3.
4. Okay. How you are sure only the 4 is there?
Sir, 4 maximum points.
So I'm asking for the critical point, not only the maximum. I'm asking the critical point. So maximum critical point.
7, sir. 7 point.
7, sir.
7.
So
Okay.
6. Last
So let's
one.
check it here.
So last one graph is not that much clear. If you can redraw, it will be better.
So this one is a smooth one. This is a smooth one. Okay. This
Okay.
is a smooth one continuously.
Then sir, 6. There are 6.
Okay, let's count it here. So this is a
So your
like
voice.
So
if
voice
you
is
draw
breaking,
the
sir.
graph here,
So your voice is breaking.
the tangent is this one.
So voice is not
So
clear.
that means this slope is going to be 0. Or by the way, or different way you can say. Okay, just a minute. I think my voice is now. It will be clear. Yeah, just looking. Now I hope it is clear now. Because okay, is it
Yes, sir.
clear?
Now
Is it better now? Is it better now?
So
Yes,
it's
sir. Yes.
having
sir.
internet issue, but it's fine.
So breaking in between all.
Am I audible?
Yes.
Okay.
Yes, sir.
Yes, sir.
Okay, let's back to this.
Again breaking, sir.
So has here. So this is going to be a tangent here. Okay. Okay, now is it clear? Is it clear now? Better now?
Yes.
Yes, sir. Better.
Okay. So here if you check here, so here is going to be tangent. If you see this is a tangent, and if you see this slope is it is going to be parallel to the x-axis. So either as now the slope is going to be 0 at there. So that's why it is a critical point. As here it is look like a minimum, but actually I purposely made here the
Sir, it's
sharp
broken.
corner is there. So here is sharp corner. In that case, here the function is not differentiable. Okay? It's not differentiable there. Still, it is breaking. Is it breaking now? Okay.
Sir, it is clear now, sir.
Okay.
It is clear, sir.
So at here the function is not differentiable. So this is also a critical point. Okay. This is 1, 2 we have. This is also a critical point. As here if you draw the graph, tangent, here is also, okay, and here is also. So
The
this is
f dash of alpha is equal to 0 indicates it is differentiable, right?
differentiable. Here is the function is differentiable in this case, but in this case the function is not differentiable. So this is one, this is fourth one, this is fifth one, and this is sixth one. This is here also the function is not continuous even. So how it could be differentiable? So at here is the also this is also a critical point. So this is seventh one, and if you here is also kind of like it is a like this is happening.
So can you explain how the 7th point is a critical point?
This one is here the function is not differentiable. No, it is not continuous. Then how it could be differentiable there? It is a discontinuous. No, here is the break here.
But 7th point is
Sir,
differentiable.
but if it is not differentiable, then how can be critical point? There is no slope over there.
No, if it is not differentiable, that's why I made a definition. No, that's why the definition of the critical point, we check that if the function is not differentiable, then in that case also it is a critical point. Not only this one, at the top corner, it is not differentiable, that's fine. But here is the break, no, is the break of the function, then how it could be differentiable there? So that point is also going to be a critical. And also here is a small one, and after this it will be very much clear, otherwise it is continuously here. So there is this one, this is 8th one, this is 9th one. So by this way, this is a rough diagram, but the mean of this one is where it is increasing to decreasing happening, or it is a break there, or it is a soft corner there. At those points the function is not going to be, at those point the function is not at those point, that point is going to be a critical point. Okay.
Okay.
So, and the process,
7th point is critical.
Sir,
how the
got
7th, this one?
Yes, sir, got confused now.
So again I am saying, no, see, at here the function is differentiable. First thing, is this function is continuous at 7 here?
No,
is
sir.
it? No, sir. So how it could be differentiable then? A function is,
Got it.
if it is a continuous, then there is a possibility that function is going to be differentiable, but a function is not continuous there, then it will never be differentiable. There is a condition, no? A function is differentiable. This implies function is continuous.
So can we calculate derivative at 0.7?
So no, we cannot conclude here the derivative. But we are sure that this is going to be a critical point.
But sir, we are calculating value of identifying critical points based on the derivative.
So that's why I think that's why you are discussing this problem. No, here is I think there is this one. So here is, I said no. I said by this way you have to derivate and find, and also you have to check at 0 the function is differentiable at not. If it is differentiable and zero is 0, then fine. If it is not differentiable, then again 0 is also be a critical point.
So by definition, it is clear that.
So we have to check. So once you started, okay, just a minute.
So by definition,
so once you started calculating the critical point, no, you have to. Function is not differentiable. Sorry. Okay. Can we move ahead with the example? With this one, even let's say I'm making a function fx is equal to mod x minus, or even let's say like this, x minus 1 minus 3. Okay. Suppose you have a graph of this function. Suppose you have a function this one. Okay. This will, sorry. Yes. Can you tell me how?
So can you explain how we can calculate the local minimum at 0.2 in above graph that you have drawn?
So that's why. So at 2 here, this one.
Yeah. Yes. At 0.2.
At 0.2 here is No, I am just not saying any. Now till now I didn't say about the. I did not say about local minima. I just said this is going to be critical point.
So critical points are
Critical
only,
point, is it clear?
so critical points are 3 points: local minimum, local maxima, and saddle point.
Saddle point. Yes, either it could be
But it is
local
neither
maxima.
neither saddle point nor looks like a turning point. It is looking like a minima, but there is no derivative possible at point 2.
Yeah, so by how you will check that? You have to take a small interval around that. Okay, you have to take a small interval around that. Okay, here the function is not differentiable, but till here the function is differentiable, till here the function is differentiable. So in this interval function is differentiable, in this interval function is differentiable. Okay, so suppose in this interval f prime s is less than 0 and in this interval f prime x is greater than 0. So this include that this is kind of local minima is happening. By this way only you can deal. For
So,
such problem. Sorry?
based on this, we can conclude that by going through first derivative, only we cannot calculate the local minima and local maxima.
No,
Or
so you cannot do using that the f prime is alpha is less than 0 or not, because the function is not differentiable. Then how it would work? For this, for such problem, you have to go with the this kind of in the you have to check around the local in this some neighborhood. You have to make a neighbor is small interval or small area. You have to you have to check here this one. Where is the function is increasing or decreasing?
Sir, it is a visual question. You have drawn the graph. Based on that, we can identify. But if function is given, equations are given, then such lengthy things to be done, it
No,
will
so
be
for such
critical.
problem, no, if it is asked in such problem, then it will be given as a more mark, and also it will so it will like it will be of more marks, and also the hint will be surely given. At least hint will be, because it is a kind of tougher, no, so it is a kind of tougher one that you have to analyze. Here is that's why this is an analysis you are doing. More in depth you are going. You have to started analysis that okay, we have to check the derivative and is this increasing, decreasing, and using that you have to conclude. For the time being, here I am just explaining as you asked how to check. Otherwise, once you have in the problem in the real life, like you have some quizzes or in the exam or graded, suppose in this problem is asking graded and function is only given. So in that case, you have a more time. You have to now check one by one, is this increasing or decreasing, and then do. If it is in which, then surely has a very quickly for a small time, you just need to suppose if this question, this problem have asked like this, then if it is this problem is there, then it will be asked like this. Okay, function is not differentiable at x is equal to 2, but f prime x greater than 0 in open interval 0 to 2, and f prime x is less than 0 in interval 2 to 4. Like this it would be asked. Now f is going to be local minima or local maxima. You have to check with the option y. See how many information is given. So if you know that concept, no, here is if you only know the concept, you can tick the option. Okay, so don't worry for such thing.
So but one doubt I want to clear over here. Such thing is not explained in the lectures, I guess. I have gone through the first and second.
So that that's needed more and more. So see, that's the thing here. If you are starting, see, if you are suppose you are studying in the classroom, okay, and professor said like this, okay, this is the critical point, like this, like this. So what you will do? You will go at home and do more practice via the book, okay, and there you find such problem. And if you are trying to solve, if you are not able to solve, then you will come to in the like here in the session, or you will come in the next classroom and then again asks professor how we will do that. So this is the way, right, to learn. So if it is not taught in lecture, but it is your also work that you need to practice more, and then if you are not getting, you can ask in the live session. So that's the purposely this live sessions are there, right?
Okay.
Okay, so suppose you have this function, no? Suppose you have this function. So by like two ways, geometrically we can do how many critical points it has, and also by the algebraic way we can think. So if you start breaking this function, it will be in a stepwise, it is in mod. So you have to check with in which case it is going to be greater than 0 or less than 0. Suppose x is less than 1. What is going to be in this case here? What it will be sign? I want to make it positive because it is always greater than 0. Suppose if x is less than 1, then in that case this portion will give minus sign, this portion will give negative, this portion will give negative. That means in the whole, if you multiply negative, 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 it will give negative. So but I want to get here the positive value. So if you substitute here negative, then it will become positive. So this is the process to making this function in the stepwise. It's look like easier, but if you draw in the Desmos, if you draw the graph, so if you start, or another way also, right? If another way, if you don't know with this way, just try to draw the graph. So if you start drawing the graph of a function, what is the first thing you will do? Anyone can tell me that if you start drawing the graph, what you will do first? It is, suppose forget about the polynomial, everything, suppose anything, there is any kind of function, but what is the first step you will take?
So we'll check the leading coefficient and second one degree.
No, if it is not polynomial, in the case of like here, it is not a polynomial, no, still it is in mod. So what you will do in the first case? Whenever you have a function, if you want to start drawing, you first find the roots. At least find the roots.
Like x equal to 1, x equal to 2, and x equal to 3.
Yeah, at least you will try to find the roots. Because once you find the root, so if you check here, 1 is going to be root, 2 is going to be, and 3 is going to be root. Okay, so if you now something we have, suppose here is 1, here is 2, and here is 3. So at least the function there, it is the function value is going to be 0. So if it is going to be 0 and it is a function, so either by this way or it is like this or like this, we don't know how it is, but at least we are sure that it is the function value at there is 0. Okay, and also one thing is, if it is suppose like this it is going, then at 2 it is 0, then it is surely back to here. Or if it is going like this, it is going like this, then surely it will back to a 2 is here, because 2 is a root. It will be like this. Okay, so here is, if you forget about this mod, okay, if you forget about this mod, so and suppose this is a simple polynomial, so if you multiply, it will be a simple polynomial. So at 1 it will be linear, at 2 it will be linear, at 3 it will be linear. The reason is the multiplicity of the root 1, 2, 3 is 1. So surely it is not, it will be not like this, or it will be not like this. So that's the one process, like this is the one way where it will be linear, it will be not linear. First find the roots roughly, and then you start guessing that where it will be linear or not. So suppose, as we just now said, that it is going to be not linear. And also one thing also in it here is note, whatever the output you will get, no, it is in a mod. So that means whenever you will try to get the output, it will be in the positive side. So in this side only the function value will lie, only this side, not go to below. Okay, so what it means that? It means that at 1 it is behave like linear, or it could be like a polynomial, but it is look like at 1 it is linear, go beyond of it, but the function value is always positive. So surely it will be back, because output is going to be like this. And also what is happening here, it is a linear, no, if it's suppose two line is actually intersecting like this, so it is linearly there, so it will be sharp corner kind of thing is happening. So roughly it will be a sharp corner then, and again it will be back to here, and again 2 is a root, so it is like this, and then again back sharply, then like this, and again this. and start like this and start like this. It is always in the positive side. Something like this, it will happen.
Sir?
And also, if you break this function in the stepwise, no, it will be also give the same similar graph. Yes.
Sir?
Yes, yes.
Sir, how we can decide sharp corner and soft corner?
So for that, so here is see. So here is actually need a more practice. If you are at so how I am doing here. At least I know that mod function at 0, it is a sharp corner. We know that, right? For mod at least at 0, where is the root for this one? It is a sharp corner.
Yes, sir.
And now if you back to here, this function is in a mod. Am I audible? Am I audible clearly?
Yes, sir.
Or my voice is breaking?
No, sir, you are audible.
Am I audible clearly?
Yes.
Okay. Okay. So here is for at least I am very sure with this one that mod is here. For mod at least it is a kind of where it is 0, it is a sharp corner. So similarly can we think here, because here this function is in mod. So mod is a property in a mod that it will be like this. These two are same actually. This is a mod one property. So actually it will take time. So I just take for this one to explain the critical point is here. For the purposely here is at 1 and 2 and 3 it is going to be the sharp corner. Okay. Otherwise, okay, so that's why using this one I said that okay, at -1 it is a sharp corner for like this. So surely here will be a sharp corner like this, here is sharp corner like this. So at this point the function is not differentiable. So these are the actually critical point. So we got that 3 points are critical point, and also see this one is local maxima, this is a local maxima. So this one is also a critical point, this one is also a critical point. The whole for this function, so whole real number, at least, not at least, we are looking actually 5 points are critical point. Okay. So let's move ahead because I once you know the critical point, I just much spended time on here. So once you know the critical point, Vicky want to ask something. Yeah, hello Vicky.
Yes, sir. Sir, I want to ask that only in the case of mod, we get the
okay. So
corners.
once you have a critical point, now suppose alpha is a critical point for function fx. Okay, alpha is a critical point. Yes.
Corners. When we get the corners, only in the modulus
yes.
case.
So in the case of mod, we get usually corner. There are other way also, like many ways. Like suppose I define a function like this. Fx is in the mod case generally. Suppose I define the function with the two linear function, at where it is intersecting.
Voice is not clear, sir. Sometime it is gone, sometime it is breaking.
Suppose at here, suppose here is this line x plus 4. Suppose I but it is a combine of two lines. It is a combination. Sorry, it is a combination of two lines. You try to graph this function. I still I need to give here there's some domain. Here is domain. So use it doesn't. Okay. Still it is breaking, or it is clear now. Is it better?
Mostly,
is it
sir, we
better?
are losing the explanation given by you.
Sir. Sir.
Right now?
No, sir, you're lagging.
Sir, no,
Uh,
sir, it's breaking.
Still
Okay.
breaking, sir.
Okay, so here is like we can, there is a possibility, like there are many ways to make
No, sir, it's severely
They're lagging on Zoom and YouTube as well.
There is a sub corner. Okay.
So you're
This
lagging.
is one part. Okay. Is it better? Today, many times it is continuously breaking. Is it better now? Am I audible?
Yes, sir.
Yes, sir.
Yes,
Now
sir.
audible, sir. Now audible.
Okay. So once you know that this prime is going to be like alpha is going to be critical point, no? So how will check that if alpha is going to be in this case, in differentiability case, if it's differentiable there and the derivative is 0 there, in that case, okay, in that case, if you have prime minima there, the function attain the minimum, local minimum. If you have double prime, okay, if double prime is less than 0, in that case, alpha is going to be local maxima. Okay, it is going to be local maxima. And for the, if you want to check the saddle point, so if it is this thing happening, f prime alpha is going to be 0 also.
It's still lagging, sir.
Cannot get you, sir. It is
So we
very
are
much.
unable to decide here. Okay. We are unable to decide exactly what is going to be happen. So again, if it is a f double prime is going to be 0, then the process will come now. F prime alpha in the small, if you take the small interval. Okay.
Your voice is still lagging. We are not able to figure out what you're saying.
Okay, am I audible clearly now? Is it better?
We can hear you, sir, but then when you start, it just keeps on, cracking.
Hello.
Yes, sir, we can hear you.
Am I audible?
Yes, sir.
Okay. My screen is well, right?
Yes, sir.
Okay. Okay, so if it is the case where the f double prime, if you calculated the double derivative, okay, and in that case, okay, is it better now? No, I hope it is clear. I don't know today is, I don't know what
So now
happened with
it's
the
fine,
internet.
sir.
Okay. So in that case, again, no, if it is a double derivative is 0, in that case, what you will do? So again, see, in that case, just now we discussed in the case here. This one, where it is. We were discussing about here. This one. In the case of here, no, as in this, we have to check is this increasing or decreasing, or similarly just now discussed here. Up to if it is unable, again it is double derivative is 0. In that case also you have to take a small interval and you have to check in this interval is increasing, in this interval is decreasing, and using that you will tell. Like let me tell you, let me take an example. Fx is equal to x cube. Okay. Suppose I am taking this fx is equal to, or fx is equal to x cube plus 3. Okay, now let's derivate this function. Okay, this is going to be 3x square, right? Now to find the critical points, equate is 0, and I solve this equation. This gives x is equal to 0 is only a critical point. Correct? Now derivate the function f double prime, it is going to be 6x, and at 0 it is going to be 0. See, the problem is here. Okay, now at double prime, once we derivated here 2 times, we got this one, and at 0 this is going to be 0 there. Am I audible? Am I audible clearly?
Yes, sir. Yes, sir.
Now we have to check here, is that point is going to be local maxima. See, by the way, by this way, double derivative test, it will not work. It will not. Still, one thing, yeah, it is that case for multivariable. So yeah, okay, fine. So this is going to be 0. Now what we can do? We have to take here. Suppose here is 0, and then let's take -1 and 1 is here. Okay, suppose here is 1 and here is -1 on the real line. Okay, and this side check the how the function is, and this side how the function is. Okay, so check this side at -1 to 0 in this interval. Okay, double prime, we have double prime is 6x. Okay, so we have double prime is 6x. Okay, this is 7. Now in this interval -1 to 0, how it will be? It is less than 0, right? It will be lesser than 0. It means that function is decreasing or increasing.
Decreasing.
Increasing.
I think I'm missing something.
If double derivative is negative, it is increasing.
I think I'm doing a not double prime. We have to check. No, we have to check for
the single.
We have to check here for single prime. No, for the checking increasing or decreasing,
Yes,
we have to check with the means single prime is here. We have to derivate once. So this is x square for double derivative. Sorry, for single derivative, this is x square. So this is going to be 0 in this interval also. Once you have to take the interval 0 to 1. In that case,
It will be positive.
okay. So in this case, again, if you check, the double prime is 3x square. In that case, in this interval. Okay, am I audible clearly?
No, sir.
It's lagging, sir.
Am I audible?
Not really, sir. We can't really figure out what you're saying.
Very sorry for such thing. Okay. Okay, I hope my voice is clear now. Is it better?
Yes, sir.
Yes, sir.
Okay. So here is for this interval also 0 to 1 also it is increasing, right? It is also increasing as if you check here in this interval 0 to 1 if substitute also greater than 0. So that means what is happening? Our function here is actually how it is behaving. Increasing at 0 is 0 and again increasing continuously it is increasing. Here is 1, here is minus 1. So see that at this is x cube we have function and at 0 it is 0, double derivative is also 0. So we have to investigate here. So once we investigate it using this derivative test, so this is using the increasing and decreasing, we got that. So it's if you check here in the graph, no, it is yes kind of shape is here, but it is not a maxima or local minima. It is, in this case it is a saddle point. It is local maxima or minima, but it is not. It is continuously increasing, and there is a small s shape, but still it is also increasing. Is it clear now how the saddle point is happening and how we will investigate a saddle point?
So 0 is a saddle point, right?
Yeah, 0 is going to be a saddle point there.
Yes, sir.
So by this way only we can investigate a saddle point. How it is a saddle point? It is you have to take derivative right side, left side. You have to check that it is increasing or decreasing. It's look like there is a set in local maxima minima, but it is not. And this tells you that it is kind of saddle point is going to be happen. Okay. Okay, so I have much explained about the local maxima and minima and global also. Let's talk a small and a brief thing on Riemann sum and integration. Okay, what is the Riemann sum? Okay, I think this is on this is all about in the critical or local maxima and minima. So let's do on Riemann sum. I just want to explain something on Riemann. Okay, so what is the Riemann sum is there means, see why the Riemann sum is came, why the Riemann is needed. So in a simple word I will say, suppose you have a graph of suppose this is a function fx. Okay, suppose you have a function fx, this one, and now all of you know the integration word, that's why I'm not going to be more deeper, but integration is nothing but the, generally we usually think that integration is a area to find the area under, like right, a square, you are able to calculate the area of this square, or triangle is there, right angle triangle, or whatever the triangle you have, you are able to calculate the area. But here is a the formula for such cases, a trapezoidal is there or anything. Okay, but what about such kind of shape is there? It is not a, it is a, you are unable to calculate if it is in such kind of shape. So how we will calculate area under this curve? Suppose here is alpha, or here is A and here is B. So how we will calculate this area, whatever inside area is there, how we will calculate? Okay, am I audible?
Yes, sir.
Yes, sir.
Okay, so how we will calculate in this case? So what we can do? So the Riemann actually what he did, he just break this small area in the, sorry, this bigger area in a small portion. Okay, in a small by this way. Okay, so what he did, he just break this one. So there are many ways actually. So first he calculate directly, like he drawed a rough diagram here and calculated the area by making a rectangle here. Okay,
Yes, sir.
by this way he calculated and said that okay, approximate area under the curve is said this one, but it is not correct. Okay, it is this portion is included in that area. So what he's tried to do, he is then started breaking that area in small portion. So see that what is shape is happening here. This is a kind of trapezoidal is actually happening here. Okay. So like this, or sometime it is a square, or it is a trapezoidal, or many ways is actually happening. So many shapes you will see there. It is like this, and again this way and this way. So to calculate this one, so we know the formula to calculate the area for this one. We have formula once you have a trapezoidal, that trapezium if you have. So, okay, if you have trapezium, you can calculate the area. But still there is a error is happening also. There are some spaces is remain to calculate, or maybe it contain more area. There is a possibility. So how you can reduce? How will find them? So there is also what we can do. Make a very small. Start breaking that area in very small portion. Very small. Started. So that's the limit word came here. Now you know, if you are unable to exact, you are unable to, like, what is the limit word here? Limit x goes to a. It means that if x goes to a means, here is, it means that you are not exactly a, but it is a very close to a. You can't even imagine how much it is close. You cannot imagine, you cannot, here is what, like in geometrically you are unable to see, but it means that you are very close. So if you start breaking like start breaking this area in very small region, very small area, you cannot even imagine that. So what is that? What is the problem? That what is the Riemann sum? Now let me write the definition of the Riemann sum. Now here is the picture came here. Suppose you want to, in this interval, okay, A to B, you want to calculate area under this curve. Okay. So just break. So like here we break now. See, these are the breakpoint we did. These are the breakpoint we did here. Okay. So just break this interval. Just break this interval and take here the left side. Or sorry, right side of this interval. You break this interval. Let's say this is x1, or let's say this is x0. Okay. This is x0, this is x1, this is x2. Like this, you are started breaking, and let's say this is xn minus 1, and this is xn, which is b here. So what I did, this is our interval is a to b, but this interval is breaked into x0 to x1 union, x1 to x2 union, like this, x1, x minus 1 to xn. In this interval, we have breaked. Okay. And in this interval, what I made here, I took the right one. Let's say this one, x1. What is here? This is x1. Okay. What I'm making here, okay, I made this one. Here is the function value. This is going to be function value, and this is the area. So function value, if you want to calculate this area, what is going to be in the formula case? How will find the area? In this case, it is a rectangle, right? So what is going to be the area? In the function case, I'm saying, what is going to be that case? Am I audible?
Yes, sir. So could you repeat your question?
So my question is, what is going to be area of this rectangle?
Length into breadth.
That is the length into.
How do we find the length, sir?
So that's the length here. How we will find the length here? What is the length here?
The
what
extension of graph.
F of x1, no? Here is, this is
yes,
the
sir, f of x at that.
Function value is there. This means f of x1. What is the breadth here? What is that? x1 minus x0, right?
Yes, sir.
This is going to be x1 minus x0. So this is the area we have. What is the area of this figure? This is going to be the area. Similarly, we can do like this for this one, this one, this one, this one. Okay. Similarly, we can do.
So why are we taking x1 and not x0?
I can take also. We can take also. So let's do this one. So if you take x0 here, the area is, see, this area is, if you start calculating, this is a more area here. Here is, this one is a more area. This one. This is a extra area which is covered. If you are start taking x0, this, then this area is become lesser with respect to if you want to accurate on this curve, on the basis of this curve. So we can calculate also, we can x0 we can take. So this is the length and this is the again breadth is there. So this is going to be again x1 minus x0. But yeah, this area you calculated this area for this one, and for previous one you calculated the whole area, this one. Okay.
Yes, sir.
So there is no issue. Everything will be rectified once we take the limit. What is the limit? We will break our area, very fine area. We will get a very small area. We will divide this figure or this area in very small rectangles, very small rectangles, and then we'll start taking the sum. And then, so again, if you start doing it here, okay, then what you will do, you find the sum, this one, like you will find the area, this one, then this one, this one, this one, this one, this one, this one, and okay, and then you will add all, okay. So maybe it will contain always greater than area, maybe it will be roughly like this, the area will come. Okay, okay, it will be contain greater areas. If you are taking the left side here, so again it will be lesser area will contain, always lesser area. Okay, but there is no issue. I am just telling about what is the Riemann sum. This is actually the Riemann sum. This is you are doing the Riemann sum. You have multiplied the length and here is the breadth. Okay, whatever the wide is there. Okay, by this way you are doing. So this is actually the Riemann sum.
Yes, sir.
Okay, so let me write the formula now. I hope now formula will be very much clear. So see, this one is called this right side. If you are taking with respect to this figure, you are taking right one. So this is called right Riemann sum. Okay, Riemann sum. If you are taking left one, then this is going to be left Riemann sum. Or in other way, this is called upper Riemann sum, because you are taking the upper one, like it is containing the more area. This is called lower Riemann sum. Okay, lower Riemann or left Riemann sum also. There are whatever the, now if you see the lecture, I hope it will be very much clear to you what is left. So this side is called right and this is called left. And there is another one. What is that? If you suppose you are taking the middle point, always you are taking the middle point. Suppose here or here, let's say we are here. You are taking the middle point. With respect to this middle point, you are assuming that this is the height and this is the width you have. Okay, this is the width you have. With respect to that, you will calculate. So let's say here is the middle one. So middle one is what is going to be the middle one point with respect to each interval. Like for this one, what is going to be middle one?
x0 plus x1 by 2.
Yeah, x0 plus x1 by 2. And at that point, find the value x0 plus x1 by 2. At that point, the function value, and then width is whatever the width you have, which is x1 minus x0. So this is called middle Riemann sum, or some other name is there. Please check with the lecture. Okay, generally middle or middle, yeah, generally lower, sorry, upper, lower, and middle. Yes, middle is there. Middle Riemann sum. Some name is there. I have to also check. Check with that. With the what is the correct word is sir have used. Okay, these there are three. Now let me write the Am I audible?
Yes, sir.
Okay. So now let me write the definition of Riemann here is. So by right sum, what is that? Right Riemann sum is, I am using the summation thing for sum f of what is here is, I am making, I will explain here is xi minus 1. I is equal to 1 to in n interval I have breaked. So see that what is here. Now one by one, let's explain it here. So this is going to be x1. Okay, this is going to be x1 minus x0. See that the first interval, this one, plus f of x2 minus x1. See that the second one will come similarly like this. Is it clear now?
Yes, sir.
Okay.
Yes, sir.
This is the right one. Left one. So left one is going to be I is equal to 0 to n f of, yeah, anyhow, see, we are now very much familiar with the
So
figure.
why 0?
Why very so here is okay, no one. Let's make it 1. If here is there is 1 we can. So what we can do, f of x I minus 1 we can write x of I minus x of I minus 1. Is it better now? If it is 0 is problem with creating the problem. Now if you check, this is f of x0, x1 minus x0. Here is I minus 1.
So can you show the right hand and left hand on the graph, sir?
So left, yeah. So left one is working for this one and right one is this one, as your left and right hand is there.
So we are only
figure-wise.
concerned about that interval, not the directions of the graph, right? Only in that interval, the left side and the right side.
So interval is happening for the same. This width, this whatever the width here, it is happening the same. Only your function value at here you are taking or at here you are taking. Based on that, your right and left sum is happening, and also based on middle one. Function value, you are taking middle one, based on that it is left, right or middle sum is happening. Okay, but width is same for each time. If you see, this is the same, this is one is same. You see in the sum is also, this is going to be the same.
Got it, sir, got it.
And if it is a middle one is happening, then middle formula is going to be summation I is equal to 1 to n again f of xi plus xi minus 1 by 2, and then again the width is will come again this is xi minus 1. Same width is there, but inside see the middle one I am taking. Okay, this
Yes,
is the left middle line. Now let's see a geometric thing. It will be more clear. I don't have that I will search, okay, in GeoGebra. Please use this one, whatever I am doing. GeoGebra, Riemann, okay. Riemann sum. So it will give you a template there. So we can visualize more here what is happening. So please everyone, okay, use this one. Okay, see now this is rectangular actual area. This is a rectangular rectangle means in this format it is happening. Actual area means finally integration have taken. But in the rectangle is in this format. So see that this is the left sum, this is the at position, it is the position is also given, and how many rectangles, like number of n is how many numbers. See, once I started increasing, suppose I took the midpoint. See, this is the midpoint. Okay, at midpoint I started taking, and I started increasing the number of intervals. See that how accurate is happening, and I started decreasing one. See, it is more area is covering or lesser area is covering. Suppose I except of middle one, I take the right sum. So right sum, see that it is in extra area is always covering, and we started number of increasing. I started here, the number of interval is increasing. Suppose here, in the case of here, I started breaking our interval in a very small interval. Based on that, I started calculating. So see, this here is happening. See, I started the number of this one is started saying the number of intervals I am increasing here. So see that what is happening. If you are take the left sum is this one. See, the left sum is always lesser than that, as I have shown you. Is it clear? Is it better? Is it a good example to see it here?
Yes, sir.
So I am giving this link. You can use in purposely. Where is that? Here is chat. Can all of you can use this for to understand the Riemann sum. So what is happening now? So this is the left Riemann, right Riemann sum. What we can do now? We can take the limit on it here. Suppose I am taking now the limit on the same here. Suppose here, so the same here. What is I am doing? Limit and goes to infinity. Here is I took the on the same and goes to infinity now. What it mean that? What is I once I take the limit here and goes to infinity? What it mean that? What the word meaning says n goes to infinity? It means that you are breaking your interval infinitely many. You are breaking your interval in infinitely many small interval. That's the meaning here. N is increasing or n is going to be infinity. That's the meaning here. If you take this limit, no, this will give the actually integration a to b f of x dx. This is the Riemann sum. Once you take the limit, this sum will become integration. This sum will become integration a to b f of x dx.
And sir, all the corners of the different rectangles will be submerged into that
Yes, because of taking this limit. No, as here you can see, once I started increasing this sub-interval, see how accurate it is happening. If it is lesser interval, see how some area is listening, some area is skipping here. Is it clear? Once I started, now this is the mean of n goes to infinity. Suppose this is still 80, no? I started making infinite. Then it is exactly the area under the curve. It will become exactly. So that's that sum and infinite. That let me tell you that limit n goes to infinity, and this sum sign will become integration a to b. This sign will become integration. Okay, this is the mean of actually happening. This is the Riemann sum. I hope it is a much clear. We'll in the next session we'll see example, or if it is some other structure we'll take. No, so please say to take this an example to solve. I hope it is clear what is the Riemann, and that's why I want to tell you like what is the Riemann sum there. Is it better?
Yes, sir.
Yes,
But sir, what is the productivity and application of finding the area under the curve? Why we find it? Why do we
So
need it?
area under the curve is, so for simple example, suppose, so see, the integration is the inverse of the differentiation. Integration is inverse of the differentiation, means here is not a kind of function as you know in the log or cos. Differentiation means you are breaking your function in small. So if you pictorially, if you see there, no, if you once you started looking there, how what is the differentiation is that you will take the f of a minus f of b upon b minus a. So what you are doing, you are breaking your function in small portion. So what is differentiation? No, the real life example, you will, what is that? Your function is here, you are very closely looking, you break your function is very small, very small, even you cannot think there. That's why the limit or differentiability came. Here you break your function is very closely you are watching, and integration is you are integrating the whole whatever you break there. So it is not only the, see, here is For differentiation is this output is coming, no? So for integration, for differentiation, always you are breaking your like this. But integration is now whatever the under is this curve is happening, you are summing them. For example, if you have a function like speed of a bike is given, like suppose with respect to time, some function is given, no? Suppose this is the with respect to time, this give you speed of the bike. Speed of the bike. So how much distance it cover? What is that? How much distance is cover? For that you have to integrate this, right? Because the speed tells you for a small time what is the exact speed? Speed, if you see the definition or speed, what is the speed? Distance
upon time.
Sir, can you please
Fine.
explain the Riemann hypothesis again?
Riemann, yeah, I will leave back to here. I will back to there. But let me tell you the example of it. So here is speed means distance upon time. So here is what is happening. You are dividing the distance with respect to time. But what is happening in integration sign? Here is dtx. You are actually multiplying time. Here is dt means here is dt means you are multiplying ht. It is a kind of multiplying. It is not happening multiplying. This says you are integrating with respect to t, but it's look like you are multiplying is here. So actually what is happening here t. So that's why it is distance will give here. Okay, so differentiation is actually in a more breaking point, but integration is you are summing them. That's why this Riemann sum is there, and after summing them in infinite time, this sum will become this sign, integration sign.
So
Yes.
we can say that in differentiation we are taking a very, very small rectangle.
Yeah, in differentiation, not rectangle, you are breaking your function in a point wise, not in area. Area will not come there. Area will come under only the integration. Your function you are breaking in the point, very small points. But in integration, you are breaking your under whatever the curve is there, under that area you are breaking your and that area in a small areas and summing them all.
So how do we get questions based on Riemann sum? Like the summation is just too big, right? Like to apply the.
So let me tell you an standard example. Generally may ask, but from the last terms you can see it is not asked. But for example, let me tell you an example. Let me give an example here. Suppose you have a function fx, okay, a simple one, x square, okay, and suppose the question will like this: consider a function, okay, consider a function fx, okay, in the interval 2 to 5, okay. Consider the function in the interval, this one. Find the left Riemann sum. But still, I just asked before asking, okay, still, or maybe it will ask like this: break the interval 2 to 5 in 3. Break this interval in 3 portions and then find the left Riemann sum. What is the left Riemann sum in that case? So what it means that you have to break your interval in 3 sub-intervals. So if we start breaking 2 to 5 in 3 sub-interval, how it will be?
2, 3, 3, 4, 4.
3, 4 and 4, 5, right? And left Riemann sum is what?
2 minus 1.
2, 3, 4, right? With respect to that, you will get the function value. So with respect to 2, this is f of, with respect to 2 function value is 2, and what is the width is here? 1. Plus with respect to 3, width is 1. Plus with respect to 4 function value and width is 1. So this is your left Riemann sum. Finally, this is going to be your left Riemann sum. Give the answer here. If it is right one, so right one is this one. 3 with respect to 3, with respect to 4, and here is with respect to 5. If it is middle one, then 2 plus 3 bracket. If it is the question will ask, find the middle sum. There is no, so middle sum means you have to break your function. So what is the middle point?
What do we have to find, sir? And then
Sorry?
find. Sir, I had a network issue.
Then find the left. This is done for left Riemann sum.
Okay, sir.
Left Riemann sum. If it is a right one, right Riemann sum, in that case, f of 3 into width plus f of 4, right one, this is going to be right one, 4 into width. For this interval, what is the right one? F
How
of
do you
5.
break up into 3 positions, sir? Should it be equal?
Yeah, this is the information given. Break interval 2 to 5 in 3 portions. So how will break? If it is given 3 portions, so what it means that you have to find the what is going to be the width there. So what you will do? You will take the greater and take the end points 5 minus 2, and how many portions it says? This says 3. So 5 minus 3 is going to be 3. It is going to be 1. So that means width is going to be in that case 1 for each interval. Is it clear now? By this way you can now break. If it is 10 in 10 time, it says that means 5 minus 2 by 10. This is going to be 3 by 10. That means you have to very clearly break your interval in that cases.
The next line, can you explain, sir? Because I'm having a network issue.
So after getting that, what is left Riemann sum? Take the left side, give in value and multiply with width here 1. For each interval, you have to do it here as here. Okay. If it is right one, then right one. If it is middle one, then f of 2 plus 3 by 2 and then width, middle one. This is the middle one. Plus f of 3 into 4 by, here is plus, no? 3 plus 4 by 2 and width. Plus here is f of 4 plus 5 by 2 and then width. This is going to be middle sum.
So all these details will be given in the question, right?
Sorry?
All these details will be given in the question, right?
All these
Left,
details.
right.
Without that, the function will be given, or sometimes the graph will be given. If you suppose the graph may be given, or surely the function, without function it cannot be. So function will be given, and interval will be given, and also how many break or how many portion you are breaking, or in breaking or interval. This information at least it will be given. Based on that, we have to find left Riemann or middle sum.
So sorry to ask, but how long is this class for, sir? Because there's another class.
No, now I am going to close. Yeah, so now I'm going to close. Actually, I almost thing of this week I have discussed. Riemann is there and critical point, and I think so. Only the integration part is Riemann. That part we can now. If you want to know the Riemann, no. So now the integration is just remembering the formulas. Integration of sine is cos, or integration of cos is minus sine. Integration of x cube is, or x to the power n is x to the.
So now we can leave the meeting, sir.
Sorry.
Now we can leave the meeting.
Yeah, you can, because now I'm not going to next do anything, because now the remaining theory part, I almost everything I have cleared. Only just integration part you need to remember. You have to remember that formula. Integration of x to the power n is what? Integration of e power is what? So you have to remember that. That's the. Otherwise, the theory part, what is that Riemann I told you? Maximum minimum I told you. What is critical point I told you? The theory part almost I have did. And also I am going to close this session. We have already one session more on Thursday. I have just given to the operational team to conduct.
Okay, sir. Good night, sir. Thank you for the session.
But we will update. Yeah. Thank you
So
so much.
when will we get the quiz 2 result?
1 or 2 days. 1 or 2 days probably. More. I'm not sure, but Just wait at generally 1 week is there, or what is the general like? What is the result once the quiz 1 is done? After how many days you got? I think 1 week.
Sir,
No.
we got it in 2 days. That was pretty quick.
So similarly, it will be like, so almost everything is done. Only need to publish the results. So you will get so similarly like by tomorrow or next day, day after tomorrow.
Sir, Thursday there will be a session.
Yes, yeah, Thursday there will be a session. Yeah, you will get a updated link. You will get a link in calendar.
Okay, okay, sir.
So hope the session is much helpful for you, but very sorry for the lagging of the internet. I don't know what happened now. See,
Yes,
this
sir,
is
the
the night
session was
time now.
really helpful.
It was very good, sir.
Helpful, sir.
Now the night is came. Now it is not lagging. That time is because of Rust. Many people are using the internet because of that. It is happening. It was happening. Okay.
Yeah, yeah.
Yes.
Yeah. Thank you so much. Good night to all of you.
Sir, excuse me, sir.
Yes.
Sir, I'm saying actually I have a general doubt that when there is a TA session, there is a CT session.
Okay.
So I mean, it's a problematic that we cannot do the both subject at the same time.
Okay. So can you tell me what is the CT TS session in timing is 6 to 8?
Yes, sir. 6 to 8.
Okay. Okay. So then I will try to make the 8 to 10. Okay. I will ask to the TA, and probably I will shift it to whatever the we have session. It will be shifted to. I will ask to TA if it is very much able to take that. I think he will surely take that. So 8 to 10 will probably.
So even 8 to 10, we have another class.
Sorry?
8 to 10, 8 to 10, there is computational thinking. There's another subject. So it's overlapping almost all the days.
So
yes,
it would be good if it is a previous before the 6th then.
Yes, sir. It will be good for from 4 to 6 or 5 to 6.
Yes, sir.
Okay.
There are working professional also.
Or there is one way, like you are one session you can attend in CT and then you can attend like TS session is not like whatever we are discussing. No, TS session is just for discuss your question, activity, practice, or direct question.
Sir,
So
we raised this concern in CT session also. They are also looking after this. I suggest it will be better if all three subject TAs should arrange they should sit together and find a solution. Session
Okay.
should be in the evening only because there are working professional like me who attend the session.
That's the problem. Like if I make it from 4 to 6, no, then working professional will not able to take that, not able to attend the session. So that's why we have 4 or 3 sessions. For TA is on Monday and Wednesday, Thursday, and Saturday. So 4 sessions we are going to continuously do that. So if you any two is attending, or sometime you are attending CT and then back to math session, then it will, I think it would work. You will never, the classing will never happen with the instructor session. Yeah, TA session is actually, there are more session is happening because of that it is happening. There are more session is like TAs is, but instructor session will never class. So the problem is like if you attend this today, you attended TA maths 1 session, next day you attend the CT session. So like that you can do also. Try to manage that. That would be also can be done. Then what I will say now. Because if I'm doing the from 4 to 6, then the many people like working professional will face issue.
No, sir. Actually, we told the CT session also. So they also accepted the request and they told that they will discuss with other TAs and find a solution so that no clash should happen. So I
There is
think
TA session for CT every day from 11 o'clock to I think 12:30, 9:30. Yeah. 11 o'clock to 1 p.m. Yeah.
11 to 1 daytime. Either there is a possibility that some session I could do for 4 to 6 and some session will be 6 to 8. If it is a 4 session, so 2 sessions will be 4 to 6 and 2 sessions will be 6 to 8 or 8 to 10.
So, but then the continuity of the class would be lost, right?
So whatever the thing, like whatever it will, you just need to check always a calendar. If it is I'm not, or if I'm not sending any announcement, then it will be updated in calendar. So updated calendar is like to is exactly whatever just now I will do, it will reflect to you. It will reflect in calendar. So whenever if it is there is change is happening, you can check with the calendar, and if it is morning, I see you. If it is earlier
But
is happening, the announcement will surely go. If it is more time is there, then just a small.
but
I think.
sir, there should be a better arrangement from the IITM side only, because they also know that how student will attend two sessions together.
So, if you are taking the next class, you will be continuing from this portion, right?
Probably a different instructor will take, but I will tell him that what will be the next one. Like integration part, he will discuss. Theory part almost we have did. Only the integration formulas are there, or need to discuss with the some examples. I
Yes,
think
sir.
Surya is going to take that.
So, and so, is there any way to communicate with the teachers or something? Because sometimes when I join the link using the link provided in the Google Calendar, it just keeps on, I just stay in the waiting room for a while and then I leave because
So it is
there won't
usually
be
for
a
TA
class.
or it is instructor also.
So sometimes it is for both, sir.
So for me, it happened for last week sessions. I
Yeah,
was
actually
not.
there is a issue happening with the Zoom thing. But now I think it will now like last two session. Yeah, I also faced the same as you are saying. So we changed the. That's why we generally change the Zoom with the Meet. But now it will not be because we Zoom have fixed now. So this issue will not with face. You will not face with the instructor session. TA session may, because if you have TA sometime like we started teaching, no. So if I usually forget to how many have you are requesting to get in, but I have already many times said that whenever you get a notification that somebody wants to in, just go there and take in. But yeah, it is a continue part that once a buddy started teaching, he forget about what sound is coming, and that's why you will usually face such problems.
So actually, when I go to YouTube to check if the class is happening, it shows live has not started yet. So I assume class has not started. There is no class. So is there any way to communicate with the faculty or something so that we get a better idea, or you know?
So better is only you just complain in discourse. That is a good thing. Like then I will get that. It
So
is
I'm
more
not in any discourse. I'm not there in any.
in discourse, or you are in Google group, that forum, forum. If you are doing this course first time.
No, I've been there from the beginning.
So first time means you are a term student or qualifier student.
Qualifier.
So then you have a Google group, no? There you can ask there, and I will get that from. There is a issue happening with this such thing.
So the faculty is there in the Google group?
So I usually watch there. So I usually see there.
So if we post doubts there, you can answer it, sir? Because a lot of emails keep on coming and then it's just a lot. So I left all those Google groups. So
Yeah,
if we post
actually,
our
in this.
doubts, we'll get it answered there.
Yeah, I just said to TS that to answer. Probably the TS were there to answer whatever you have doubt. You can ask, and generally Ganesh is there usually answer those all doubts. Sometime I also used to answer.
Okay,
Sir,
sir.
on
Okay.
Friday there is a morning class.
Which class?
On Friday.
Morning class we have, yes, and that would be
Sir,
for week 10.
Week 10 or week 9?
Week 9 and 10 in both mixed form.
Actually,
So,
sir, we are written week 9.
So on Friday it's okay. Just a minute. So it will be in the mixed form because only two sessions we are doing for week 9, and then onward. So it will be in a mixed form. No, this is that would be the first session of. Let me check once. On Friday. This is August. So this Friday we have open session for week 9. It is no, so it is in the mixed format. Okay. Somebody's have doubt on week 9 also, because this is the last day of week 9. This would be the last day for week 9. So it could be asked, like you can ask your doubt from week 9 also, and it will be of week 10 also. Okay? This is the first session will be of week 10.
Okay, sir.
Okay. Okay, so thank you so much. Now I'm stopping the
sir.
session.
Okay, sir. Thank you.
Thank you very much, sir.
Thank you, sir.
Thank you so much.
Thank you, sir.